Hello, it's Mr. Townsend here. Now I'm just going to have a short video here on atomic structure. We're going to look at what atoms are made of and some properties of electrons and protons and neutrons. So here's an example of a lithium atom. If we look at the periodic table, we see that lithium has a wee number at the top left. It says 3. That means it's atomic number 3. It's the third atom on the periodic table. And what that means is that we'll have 3 protons, that's the wee black ones here, and it will also, the neutral atom will have 3 electrons. Now the electrons are arranged in shells around the atom, and the first shell can hold 2 electrons, the second shell can hold up to 8 electrons. The third shell can also hold up to 8 electrons. Notice here this atom also has 4 neutrons. But we're not going to go into that detail at the moment. The atomic number, which is number 3, is equal to the number of protons. That's its definition. But as I said before, it's also equal to the number of electrons. The mass number, that is how heavy an atom is equal to the number of protons plus neutrons. Now there's a reason for that, and we'll go into that in the next slide. Right, the reason that the mass number is equal to the neutrons plus the protons, and it doesn't include the electrons, is the electrons are so much smaller in mass than a proton and a neutron. In fact, an electron is 1/2000th the size of a proton or a neutron. And a neutron or a proton are equal to 1 atomic unit each, or 1 unit. So if an atom has just 1 proton, it is 1 atomic unit in mass. If it has 2 protons and 2 neutrons, it's 4 atomic units in mass. The number of electrons doesn't matter. So a proton, we can see here, has a positive here because it has a positive coulombic charge. So it's a positive charge. An electron has a negative charge. Now the size of the electron's negative charge is equal to the size of the proton's positive charge. That means if an electron and a proton are in the same atom, their charges will cancel and the atom will be neutral if we have the same number of protons as electrons. A neutron has no charge, hence its name neutron. Okay, so that's the basics of an atom. I guess the next thing we have to talk about with an atom is the relative size of an atom. So to understand that, I want to talk about a basketball, a football, and a table tennis ball. So the relative sizes of the different particles within an atom are a neutron, size of a basketball, proton, size of a football, same size, but an electron the size of a table tennis ball. Now if we can imagine that we have a running track, a 400-meter running track, and we have a field in the middle of it. If this is the center of this running track, and this circle here represents the outside, so the center of the circle is where the nucleus would be. And you can imagine, let's say for this lithium atom, we had 3 basketballs and 4 footballs or soccer balls sitting in the middle here. The electrons would be the distance shown by this dotted circle here away from the nucleus. And the electrons would be a relative size of a table tennis ball compared to the relative size of our basketballs and our footballs for our protons and our neutrons in the middle. What that means is an atom mostly consists of empty space. And the reason an atom seems like it is solid is because the electrons, or these wee table tennis balls going around the outside in this shell, travel so fast that when something comes into contact with the outer of the shell, there's always an electron in the way of it. It's like a propeller on an airplane. It's traveling so fast that it makes a solid barrier, and it does this in 3 dimensions. Well, that's introduction to an atom, and I hope this has helped. Make sure to look into the next video where I'm going to be talking about ions. Thank you.